So this video is going to go through 10 different examples of balancing equations so that you can see the steps that I would take as a teacher for how to go about balancing different ones, and they'll get increasingly difficult as we go along. So the first one, what we've got here is we've got an equation with carbon, bromine, and then the CBr4. So the first thing I would say is that I've got one carbon on each side. So carbon is balanced. When it comes to bromine, we have got 4 bromine here, but we've got 2 bromine here. So the question I have to ask myself is, how do I turn this into 4 bromine? And I'll need to multiply by 2. So I'm just going to put a big 2 here. And you can see now I have 1 carbon on the left, 1 carbon on the right, 4 bromines on the left, 4 bromines on the right. This one is balanced. Our next one here, well, we have got 1 sodium on the left and 2 sodiums on the right. We have got 2 oxygens on the left and 1 oxygen on the right. Now, this oxygen is an O2 and this oxygen on the right hand side is part of a molecule. So those two are linked, and our sodium, because it's just sodium on its own, is going to be the easiest thing to balance. So I'm going to do it last, and I'm going to look at my oxygen first. So I've got 2 oxygen here, I've only got 1 oxygen here. I need to make it into 2 oxygen, so I'm going to multiply it by 2. So I'm going to put a big 2 there. Now, I've got 4 Na here. I've only got 1 Na here. I need to make that 4 Na. To do that, I'm going to multiply by 4. So I'm going to put a big number 4 here. 4 Na and 2 oxygen on the left-hand side. 4 Na, because this big 2 multiplied by that small 2 gives me 4. And this big 2 multiplied by my 1 oxygen gives me 2 oxygen. So this one is balanced. For the third one, well, I've got magnesium, 1 magnesium, 2 oxygen on the left-hand side. I've got 1 magnesium, 1 oxygen on the left-hand side, on the right-hand side, sorry. So our oxygen aren't balanced. So I've got 2 oxygen, I've got 1 oxygen. I need to make that 2 oxygen. To do that, I would multiply by 2. So I'm going to put a big number 2 in front of there. Now, this big number 2 tells me I've got 2 magnesium. I've got 1 magnesium. I need to make that 2. To do that, I would have to multiply by 2, so I put a big number 2 here. 2 Mg on the left-hand side, 2 Mg on the right-hand side, 2 oxygen on the left-hand side, and 2 oxygen on the right-hand side. That one is balanced. This one, and now this is something that is going to be quite common, particularly with chlorine and elements like iron and aluminium, where the valency is 3. So if we look, we have got 2 chlorine here, and we've got 3 chlorine here. Chlorine. There's no number that we can multiply one of those by in order to end up with the same number as the other one. 2 would have to multiply 1.5. So actually what we're going to have to do is think about what's a number that we can reach with both of them. And with 2 and 3, we're always going to be able to make 6. So I can get to 6 chlorine by multiplying this by 3. I can get to 6 chlorine by multiplying that one by 2. So if you've got an odd number on one side and an even number on the other side, you're probably going to have to multiply both by a number. Now all I need to do is look at my aluminium, which is easy because we've got an aluminium on its own here. Got 2 aluminium here, got 1 aluminium here. I need to make it into 2 aluminium, so I'm going to have to multiply by 2. So I'll put a 2 there. 2 aluminium, 6 chlorine on the left-hand side, 2 aluminium, 6 chlorine on the right-hand side. That one is balanced. This one is pretty straightforward, but we have to think about what we've got. So I've got 1 sulfur, 1 sulfur. See, when we've got a situation like this, every sulfur atom on the left-hand side is producing 1 sulfur on the right-hand side. So no matter what we do to our SO2, we're going to have to do the exact same to our SO3. So those are always going to be balanced. Now, if we look in total, I've got 4 oxygen here. In total, I've got 3 oxygen here. So I've got an odd number on one side and an even number on the other side. That's not great. What I'm going to do is I am going to make this no longer an odd number, I'm going to put a 2 there. And remember, because every sulfur atom ends up here, I also have to put a 2 here. So that's leaving me with 2 sulfur and 2 sulfur. If I look at my oxygens, I have got 2 times 2 oxygen, which gives me 4 oxygen here. I have got 2 oxygen here, and I've got 2 times 3 oxygen, which equals 6 oxygen. And if I add those together, 6 oxygen, 6 oxygen, those are balanced. I don't need to do anything else. So that one is balanced. Remember, if an element only appears in one chemical on the left-hand side and only in one chemical on the right-hand side, those two chemicals have to have the same number in front of them. This one is actually quite a nice one. I've got 2 hydrogen and I've got 2 iodine, but I've only got 1 iodine and 1 hydrogen. So for both of these, I want to end up with 2. So I need to multiply by 2 for each one. So I just need to put a big number 2 in front of there to make it balanced. So this one is a similar one to the one we had a while ago. Because we've got our 2 chlorine and we've got our 3 chlorine, there's no number that we can multiply one of them by to give the other number, so we're going to have to multiply each one. So I'm going to multiply this one by 3 and multiply this one by 2 to give us 6 chlorine. So that means I'm going to put a big number 3 here, and I'm going to put a big number 2 here. So our chlorines are balanced. What we need to do now is look at our phosphorus. So we've got 2 phosphorus. I've got 1 phosphorus. I want to make it 2, so I'm going to multiply by 2. 2 phosphorus on the left-hand side, 2 phosphorus on the right-hand side, 6 chlorine on the left-hand side, 6 chlorine on the right-hand side. That one's balanced. Now we're getting into our harder ones. Now this equation is one that when you do Unit 2, you'll actually do quite a few balancing of chemicals containing hydrogen and carbon when they react with oxygen, what we would call a combustion reaction. Now the rule for ones like this are to do carbon, then hydrogen, then oxygen. Now if we look, carbon only appears in CH4 and it only appears on the right hand side in CO2. So we have to balance the CO2s depending on how many carbons we had here. So we had 4 carbons here, we have 1 carbon, we need to make it 4, so we're going to have to multiply by 4. Our hydrogens, all of our hydrogen is in the C4H8 on the left hand side, and all of our hydrogen is in H2O on the right hand side. Now here we have 8 hydrogen, here we have 2 hydrogen. We want to make it into 8 hydrogen, so we have to multiply by 4. So we'll put a 4 there. Now we'll deal with our oxygen. We have 2 oxygen on the left-hand side. With our oxygen, we have 4 multiplied by 2, which is 8 oxygen for the CO2. And here, we have got 4 multiplied by 1, which gives us 4 oxygen. When we add them together, that is 12 oxygen. So we want 12 oxygen here. So we're going to have to multiply by 6. So we're going to put a 6 there. Always with these ones, look at what is limited. The CO2 is limited by how many carbons there are on the left-hand side. Your water is limited by how many hydrogens you have on the left-hand side. Your oxygen is the thing that is the most flexible, the most changeable, so deal with it last. Here we have an equation, and this is sometimes where it's important to remember that some elements are grouped together. So, for example, in this one, our sulfate and our sulfate are linked. All of the sulfate in our product, SO4, is going to come from this chemical. So however many we have of this product, we're going to have of that H2SO4. If we think about our NH4, and if we look at what we've got here, we've got NH3 and we've got H. NH4 is equal to an NH3 and an H. Now we have 2 NH4s, so that means we're going to need 2 NH3s and we're going to need 2 hydrogen. Now our 2 hydrogen, we actually have 2 hydrogen here, so that's already balanced. Our NH3, to get 2 NH3s, we would need to multiply by 2. So we're going to just put a 2 here. So when NH4 comes from NH3, every NH4 needs an NH3 to make it. So if we have 2 NH4s, we'd need 2 NH3s, and the hydrogens are coming from the H2SO4. So this one, we only needed to do one change, but it was important to recognize that our NH4 comes from combining our NH3s, our ammonia, with our hydrogens from H2SO4. Our final one was by far the hardest question. So with this one, the difficulty is knowing where to start. And in this one, you actually have to do quite a lot of changes to it. Now, if we look here, all of our NO3 is going to end up here. All of our hydrogen from HNO3 is going to end up here. And so we're going to have to find a number of HNO3s that can give us an even number of hydrogens and an odd number of nitrates. So we want 3 nitrates and we want 2 hydrogens from something that only contains equal numbers. So that's not going to be possible. There's no number here that gives us 3 nitrates and 2 hydrogens. So we're going to have to think of something that could maybe deal with 3 and 2. So when I think of this, I'm thinking 6. So I'm going to put a 6 here. And so that's 6 hydrogens and 6 times NO3. Right, so I've got 6 NO3 here. I want 6 NO3 here. So to go from 3 NO3 to 6 NO3, I'm going to multiply by 2. So I'm going to put a big number 2 here. For my hydrogen, I thought, because I got a 3 and a 2 here, I thought number 6. So I'm going to think, can I get 6 hydrogen here? Well, to get from 2 hydrogen to 6 hydrogen, I can multiply by 3. Oh, let me undo that. 3 hydrogen here. So if we look, I've actually balanced at this point, we've balanced out our hydrogens and we've balanced out our NO3. See, if you've got something in brackets like that, keep it together. Don't treat it like separate nitrogens and separate oxygens. All that's left is for me to deal with the aluminiums. Now here, I've got 2 aluminiums. Here, I've got 1 aluminium. So I need to get to 2 aluminiums. So to do that, I'm going to multiply by 2. So what I end up with is 2 aluminiums, 6 HNO3s, which is nitric acid, 2 aluminium nitrates, and 3 hydrogens. The hard part is identifying that these two things, your NO3s and your hydrogens, are coming from your HNO3, and so you need to think of a way of being able to obtain 3 of one and 2 of the other. And the only way I can do that is by getting something that both numbers multiply to give, which is 6, and starting from there. So hopefully that was useful, and these were questions that were on a worksheet for you to practice, but by watching this when revising for any of your Unit 1 or final exams will hopefully be very useful to you. So thank you for watching. Any questions, just come and ask me in class.